All right, math doers, part 2 this week, finding missing segment lengths. So today we're going to be looking at some examples together and identify rules to follow. After a review, you're going to be asked to record your answers as we go through 10 problems that show up on the screen. This will be what you submit for your assignment. So pause the video, grab a plain sheet of paper, and number 1 to 10. Meet you back here when you're ready. All right, so let's take a look at some examples of what I mean by finding missing lengths. So you're going to be given the lengths of segments, and you're going to have to identify the third segment. Using a number line is very helpful, so it provides a visual for you. So let's take a look at number 1. So it tells us in number 1 that UV is 17. So here's U, and we're going over to V. We know that that measurement is 17. It also tells us in the problem here that SU is 38. So here's my S, and I come over to U, and again, it tells us that that measurement is 38. So I'm going to go ahead and label that. The question in general is asking us to identify or find the length of SV. So here's my S, and I'm moving it on down to V, and I want to know the total length. So if I start at S, going on my blue section there, we know it's 38. Then moving on to V, I'm also including my green section, which is 17. So hopefully you can see that you would add those values together. So you have 38 plus 17. So SV would be 55. And again, go ahead and grab that standard calculator on your computer if you need to, or basic calculation can also be done on your phone. Okay, taking a look at another example. So the first part tells us that we have RT, which is 15.3. So R to T, 15.3. And then we have TW, which is 17.5. So here's TW, 17.5. And my problem is asking me to find the length of RW. So here's R, moving on clear down to W. You should notice that it encompasses both the green and the blue section. So it'd be 15.3 plus 17.5. So getting out my calculator here, 15.3 plus 17.5. And you get the answer of 32.8. So we're going to write down here, RW equals 32.8. And actually, let me jump back up to number 1. I also forgot to mention, and I did something that I don't prefer, but if it's asking you to find the measurement of a value, you should label it as SV equals 55. This was kind of my scratch work to figure out my answer. Here is my actual answer, establishing that SV, the line segment there, is 55. Number 2, I didn't necessarily show the calculations. You can if you'd like, you don't have to, but the most important part that you do include is the label equal to your answer. All right, so taking a look at a rule. Both these examples, we had segments or color blocks. Since I highlighted, you can kind of see the blue and the green segments were next to each other, right? So what operation do you use when segments are next to each other? You're going to add. This will always be the case because you're putting together two smaller parts. We're adding them to find the distance of the largest. Okay, let's take a look at two examples that have a different rule to them. So if we take a look at number 3, it says RS is 19. So RS is 19. Then it says RV is 71. RV, so there's RV. It is 71. Now, if you take a look this time, it's asking us to find SV. So it's asking us to find from S to V. So it looks a little bit different this time. If you notice, our blocked segments are overlapping. And so in a sense, hopefully this makes sense to you, I would be looking to, oh, it's not going to let me do it just for that blue segment. There we go. You're in a sense looking for, now see I'm moving my blue line. I am taking away this much to get it to equal that same distance as that Same distance as my purple, correct? So I would be taking away this much of 71 in order to get the same distance of my purple. So hopefully you can see that visual. If you cannot, hopefully maybe you just see that it would be subtraction because I am taking away, again, this portion. So I would be taking 71 and subtracting this time my 19. We would say 71 minus 19. And you get the answer of 52. And again, just like the last section, make sure that you are using the labels correctly. SV equals 52, because that's what we're really trying to find. So that is much more important than the actual computation being shown is the answer. Okay, so for number 4, similar example, just to show you again. This time it says Vx is 13. So here's V, moving on over to X, and it is 13. And then we've got our blue segment here. So we'll make this green, and then we've got our blue segment of SX, which is 30. And I'm just doing it above so you can see the color blocks. This would be 30. And my question is asking me to find SV. So SV is from here down to here. Again, I know that this whole blue is 30. And if I were looking for just the length from S to V, let's see if it'll let me do it again here. I would be looking to take off, I'm only looking to measure this, right? If this whole thing is 30, if I'm taking away this amount to span from S to V, I'm taking away this green amount, right? Which is the value of 13. So I would be taking away, or subtract is what take away means. So 30 minus 13 would be your computation to figure it out. So 30 minus 13, and you get the answer of 17. So again, labeling is important when we're establishing our answers. So it's asking for SV. So in this scenario, SV is, oh, I already forgot my answer there, 17. So the rule. So if you take a look at these examples, we have segments or color blocks, since you can see it in color here, that overlap. So for these type of problems, your operation that you're going to use is subtraction. So you would subtract your numbers. All right, so this is where you're going to need that paper from 1 to 10. So what we're going to do is kind of play a little game of what would you do? Add or subtract? And I guess, oh, I can move my screen up there. So what would you do, add or subtract? So you're not actually finding the measurements for me. I want you to look at the color blocks and I want you to tell me, am I going to add or am I going to subtract? You can use symbols or you can actually write out the words. So for number 1, what would you do? It gives you the information down in blue about the segments. Again, you're not actually solving, you're not telling me what AAF is. I just simply want to, for today, I want you to tell me whether you would add or subtract. Pause as you need to. Number 2, what would you do? Add or subtract? Number 3, and again, you can put the symbol, you can write it out, whatever is easiest for you. Number 4, what would you do? Add or subtract? Number 5, okay, so number 6, you see the number line above there. You see the information there below. So what I want you to do is, my color blocks aren't there. What I want you to do is you kind of imagine the color blocks, write it down, pause it, take a minute. But again, you're looking for whether my segments line up next to each other, whether they overlap. And the final thing I want from you is to write down for number 6, what would you do? Add or subtract? Same for number 7. Go ahead and figure out where those segments are located on the number line. And then tell me, what would you do? Add or subtract? Number 8, add or subtract? Number 9, add or subtract? Last one here, add or subtract. And again, you're not calculating the answers. All I would like for you to do is tell me adding or subtracting. Once you have this one finished up, go ahead and hit submit on the assignment tab, and you're going to type in for me your answers 1 to 10.